thanks so much to the team here. We're going to do an AMA on Eth2, and Danny, Xiao-Wei, Proto, or Diedrich, whichever you like to go by, Aditya, and then Ben, thanks for joining. I'll let you guys take it away from here.
Cool. Welcome, everyone. This was DeFi Dad put this on last minute at my request because I thought it'd be fun. Obviously, we have a bunch of different Eth2 experts. I think there might even be some more people in client teams lurking. Holler if you want to hop on. And mainly just want to give a forum for people to be able to ask questions. There's a lot going on with research and specs and test nets and optimizations and when and all sorts of fun stuff. And you know, here's a forum. And if you don't have any questions, I'll just ramble for however long I have. But cool. Quick intros. I'm Danny Ryan. I work at the Ethereum Foundation. I work a lot on spec writing, coordination on this big fun project, and just try to keep things moving forward. Xiao-Wei.
So I also work for Ethereum Foundation, and currently we are working on mostly about the spec and coordinating with the client teams with Danny.
Sweet. Aditya?
Hi guys, I'm Aditya. I work for the Ethereum Foundation on the Eth2 research team. I review specs, make sure everything looks good, try to push out formula verification stuff, and other cool testnet stuff.
Nice. Ben?
Yay, I'm the imposter here. So I'm not Ethereum Foundation. I'm a product owner for Teku, which is the Eth2 client from Pegasus Consensus Protocol Engineering Group. Which just synced Schlessley, the multi-client testnet, in the wee hours of the morning, I believe, or day, depending on where you are. Diedrich?
Hey, hello. So I'm Proto Lambda, or Diedrich. I also work on the Ethereum Foundation research team. I work on a lot of tooling for Ethereum too, some testing, work with clients, that kind of thing.
Fun fact, Diedrich recently produced a piece of software that he can control via Telegram and essentially control a botnet via Telegram. Cool stuff. It looks like someone else from my team likely joined with my link and has my name. If that's true, you can introduce yourself. Okay, never mind. So if you are the second Danny Ryan and want to introduce yourself at some point, go for it. Otherwise, you can lurk.
Hey, Dan, I can unmute that. I can unmute your twin if you want for a sec. I think that'll help you. Here we go.
Unmute my twin?
Yeah, there we go.
Yeah.
Danny, can you speak now?
Oh, am I the other Danny? This is so weird. Oh, I followed your link.
I didn't know that it was a specific link for me, but Justin, welcome to the party.
Oh yeah, hi, I'm Justin Drake from the Ethereum Foundation, and I do Eth2 research.
There we go. Justin, I updated your name, and I'm moving you to a panelist here, so you'll be able to control yourself. Cool.
Thank you so much.
Sweet. Okay, so it looks like there's this Q&A format. Obviously, you can ask questions there. And I know there's also this chat. We'll try to keep monitoring both, but try to ask questions in the Q&A. So we have one question. Well, we have two questions. He just says, hey, I'm gonna click answer and I'm gonna click done. Tyler Smith, thanks for doing this. One of the concerns that has been raised is the decentralization of staking hardware, that many will choose to use cloud hardware to host their nodes. At what percentage of nodes on the cloud would you start to be concerned about hardware centralization? Good question. I'll take the lead on that. So one fun fact, well, absolutely, there's concern here. And my concern is slightly with cloud in general, but more with like super centralization on a single cloud, probably namely AWS. You know, if everyone's on AWS, I think that's not a good outcome. And it might be a reasonable outcome for a while until like one of those tail risk scenarios come and like AWS goes down, or like Jeff Bezos decides to be crazy and does something weird to Ethereum. And in that case, we learn our lesson, probably fix ourselves and move forward. But issues with centralization. One interesting thing about the spec is that there are anti-correlation incentives, meaning that there's ways to lose money. There's ways to make money, just generally doing your job, having good uptime, but there's also ways to lose money. One of which is being offline, one of which is doing something explicitly nefarious. Both of which are compounded if you do it highly correlated with others. So if you go offline, you're on AWS, AWS goes offline, you're going to lose not just a little money, but probably a lot of money. If everyone is on AWS, for example, if half the network has an outage due to something like that. So there is a fundamental incentive. It's unfortunately, it kind of shows up in these tail risk scenarios. So ideally, there's good education and people, want to diversify. Similar with the slashing stuff, you don't want to be slashed at the same time. So you want to use different clients. You don't necessarily want to be highly correlated with others. But what percentage of nodes on the cloud would you start being concerned about hardware centralization? Let's assume it's just distributed on the cloud. Does any of the other panelists have a thought on percentage cloud versus home versus local server kind of stuff?
Sure. So just rough figures here. 1/3 of the stake on like a single cloud provider is doomsday scenario. Basically, it means one cloud server somewhere goes down, and a $30 billion network just goes offline. Because if you have less than 2/3 participants in our proof of stake network, it's going to stop finalizing stuff. You stop making progress. So 1/3 is definitely doomsday scenario, but realistically, I would start getting worried somewhere around 1/6, because that's where weird kind of network attacks become possible.
1/6 on a single server provider or on cloud in general?
I would say 1/6 on a single cloud provider.
What about, anybody have thoughts on ratio of distribution, healthy distribution between cloud and home staking hardware in general, not assuming that cloud's very centralized?
I mean, one comment that could be made is that a validator doesn't have to be fully on cloud or fully on their home computer. Like, there are like backup mechanisms, there's threshold mechanisms, so you could have multi-cloud, you could have 2 clouds and 1 at home, and if AWS goes down, then you can have your backup at home or something like that. So even though it might seem that in the optimistic default scenario, let's say 1/3 of the validators are on AWS, that might actually not be, doomsday scenario, because if AWS goes down, then there's all these backup mechanisms that kick in, and those we don't really see them, but they could exist.
Right. And some of this stuff doesn't necessarily exist today, but the systems are generally designed such that we can attempt to do load balancing and backups as the system matures over the next some amount of months. I know Eth2 in general has also been looking at how they can do horizontal scaling and kind of load balancing across different servers and things. So there might be some cool redundancy mechanisms available there. Cool. Thank you. I was done on that. Does anyone know what clouds? I guess I can be more selective about these, but clouds that Coinbase and Binance use, no idea. Probably none of them know. But if you were using Coinbase, the assumption is you're using now a kind of a centralized service provider. Similar mechanisms, like we really don't want to see over 1/6, over 1/3 on one of these providers, but similar to correlations on cloud providers. Okay, done. Okay, I haven't pre-read these questions, so I'm gonna like quickly pre-read it and then summarize it. Gotcha. So this is about one-way bridge, about unknown lockup times associated with early phases of phase 0, of Eth2, and liquidity options for rewards. So just a quick background on that. So Eth2 is developed in phases. Phase 0 is really like the core system infrastructure, the kind of the backbone of the consensus mechanism of this new proof of stake and sharded infrastructure. Phase 1 is adding the shards. Phase 2 is this nebulous thing where ETH1 is integrated and execution is also layered into these shards. In early phases, especially certainly with Phase 0, there is no mechanism to transfer ETH or necessarily withdraw it. Really, if you're becoming a validator, you're making a commitment to be in it in the long haul. The long haul being, you know, at least probably a year, unknown lockup period here. So you're taking on risk with not having liquidity on these assets, but there's also potential benefit because the risk is there. There's going to be higher returns because there could be higher returns because there could be fewer people staking. So there's a balance there, and the mechanism does attempt to find, you know, the right risk-adjusted reward based on the amount of people that are staking. So unknown lockup, no liquidity. There's really no way to exit the system at the start. And so the question becomes, is there something planned to allow for staking rewards sooner? There's a few potential mechanisms there. One would be adding transfers into the beacon chain, essentially validator transfers. This would enable liquidity and likely enable you to move your assets onto you know, an exchange, trade it with other users. So a market could emerge. You could get some rewards. This mechanism does not exist in Phase 0. It was previously specified and removed for some technical reasons, probably some political reasons, and at some point is likely to be potentially added in. It really depends on the shifting timeline between when is ETH1 integrated, because at that point you also get liquidity. So essentially, liquidity events can be adding transactions, adding validator transactions, integrating ETH1 into ETH2, doing an ETH1 ETH2 bridge, bidirectional bridge, which seems less and less likely because people will really want to see the ETH1 integration in ETH2, or like the full-blown Phase 2. All of which are options, one of which will certainly happen. Timeline there, unsure. I haven't fully vetted the mechanism that you proposed there with the smart contract controlling the withdrawal keys and pulling out rewards, but it becomes very difficult to, in the single directional bridge at the start, you can't really make proofs about the system state of ETH2, and so it's very difficult to like come up with things to remove tokens from that contract and get early liquidity. So there's definitely some unknowns there, definitely some associated risk with this unknown lockup. Be aware of it, make an informed decision, read up on it, think about it. And if you're all in, if you're a hobbyist and you want to get in on this thing, probably get some good rewards to start. Does anybody else have some thoughts on that one?
Yeah, I think this is going to happen. People will, exchanges will create derivatives based on future staking rewards. They will be tradable in certain ways. It will be a centralizing force because, for example, if Binance or Coinbase have the majority of that token, and then people will want to stake with them in order to be able to use those derivatives because they're more fungible and so on and so on. So yeah, I worry about this. But it's temporary, right? I mean, the sooner we can get, as Danny says, ETH1X into ETH2, then everything becomes liquid. It's much easier. So you can certainly have centralized mechanisms to do this, but there's also, you can very simply write a wrapper contract on deposits and create your own synthetic, essentially rights to, well, I don't know. There's some complexities there, but I think there's going to be a number of things that do emerge because it's an open market and people are going to try some stuff. So be ready, be aware, read about it, think about it. Phase 0 is going to be the Wild West.
I mean, in theory, it is possible to have an ETH2-like client written in an ETH1 smart contract and being aware of all the balances and things like that, but it seems far-fetched that someone would design this sophisticated infrastructure, especially when you need pre-compiles like BLS 12381 pre-compile, which isn't even ready.
Yeah, so you could do that, and then you could create some sort of like synthetic assets based off of something related to it. So that, you know, people have done crazier stuff on Ethereum, so we'll see. Quick one. Do you want lots of people to create validators, excuse me, now on the testnet? So there's a couple testnets. Prismatic runs their own kind of single client testnet called Topaz. Afri launched a testnet called Schlessley, which is multi-client testnet. It's very small currently on number of nodes and number of validators, and it's not likely to be persisted indefinitely. It will be restarted, you know, every 1 to 3 weeks as we kind of work through stuff. But does anyone want to actually answer? That's the background on what the testnets are. Who wants to answer the question of should people be creating validators and joining and trying it out?
Yeah, can do. I mean, I think Topaz network explicitly they'd like people to join. I think the more the merrier, and it really tests the infrastructure nicely. Schlessie, as Danny says, is a little experimental just yet. It might be worth creating 1 or 2 validators, but I would suggest people don't want to overwhelm it, at least for the next 2-3 weeks.
Yeah, give it a shot, but know that especially on Schlessie, it's highly experimental. At least today. Diederik had some fun yesterday.
Yeah, like DevOps can be fun. Anyway, what I wanted to say is that if you're hopping into a testnet, there are these Discord servers for each of these testnets where you can get help of the people that manage the testnets that started them. And so you can share like resources and ask if you have like stumble on some bug or something. Or just need help setting up your node. So Prismatic has their own Discord server. They have lots of different resources. And Schlessie has a sub-channel in the Ethereum 2 Discord.
Yeah, and a note on being a participant. It is obviously very valuable to you to join these nets if you're interested in staking and getting involved with these too. But it's also very valuable to clients and to the network in general. Like you're the first users, you're the early adopters. There are going to be bugs, there are going to be weird things, there's going to be issues in docs. You know, if you're new to being involved with open source, like if you find an issue, at the very minimum, let somebody know that the issue exists. You know, go on to GitHub, go on one of these Discords and like file the issue, make sure that it is known. Because just because you're experiencing a bug doesn't necessarily mean that I or the client team has ever even seen it. And so, sharing in this project and kind of being involved on a more tangible level is going to be super valuable to both you and and the entire community. Even fixing typos in docs is like super welcome and makes everything just like that much better.
So if you're keen to help the effort with reporting bugs and things like that, one of the things that the Lighthouse team is looking to do, and this is quite a recent idea from I think yesterday, but they're keen to do it, is basically to do fuzzing at home. So the Lighthouse team will prepare like a Docker image, which will fuzz all the clients for crashes, and then further down the line, differential fuzzing. And you just run the Docker at home, and when the fuzzer finds something, either you need to manually report it or it gets automatically reported. But I guess that's kind of a low effort way of making a contribution.
Yeah, as that progresses, keep an eye on the Eth2 quick updates, keep an eye on Ben Edgington's what's new in Eth2, and we'll keep you informed. There's also an ongoing phase 0 bug bounty. This is related to the specs, so it's definitely not something you're necessarily going to touch just by running clients, but if you want to get involved, find the bugs, fix the bugs, there's some rewards available. And further down the line, there might be some bug bounty programs related to the clients themselves. Cool. Someone asked a question. Nathan does. Sorry, I didn't say anyone's name, and I decided to say your name, and I can't say it very well. I apologize. Thank you for the question, though. Currently on Ethereum, there are many atomic transactions that are important to the ecosystem and rely and interact with multiple dApps. Specifically, you see this a lot in DeFi. How is this going to work if contracts are deployed on different shards? Is this a contract design issue, or will some of these types of transactions no longer be feasible? In the event of multiple shards with execution across each, there will be a cross-shard mechanism, cross-shard communication mechanism, cross-shard transaction mechanism, in which I'm on shard A and I can invoke a message that gets picked up and consumed on shard B to interact with something else. In the optimal and in the normal case, this happens on a single slot basis. So I do something in one slot, 12 seconds later, it happens in the next slot on that other shard. Communications can kind of bounce around between things. Obviously, this is but within a single shard, you could still have these more dynamic calls. Obviously, this is very different. There's a few ways to, and for a lot of things, I'm like paraphrasing Vitalik this morning because I think he answered this same question. But for a lot of things, this is probably fine. Payments, different token transfers. But for some of the more interesting things that people have been coming up with recently, there are some alternatives. One of which is this notion of yanking, where potentially different subcomponents of a contract are their own contracts that can be moved around. For example, I want to book a train in a hotel, and essentially there's this notion of the train car seat and the hotel room being derivative contracts. I pull them, I yank them into one contract, and I atomically book them. So yes, that ends up being a contract design issue rather than a fundamental issue. And so one of the things is we're going to have to be able to think about things in a multi-chain sharded universe, and probably some of the token standards are going to evolve. But certain applications, I think, will still probably try to live close to each other and do things such that they can be computed on in single transactions. So it's really, there's a few different fundamental mechanisms to solve it. One is the asynchronous communication, one is the yanking mechanism, potentially others might emerge. It then at that point really becomes kind of a design issue. Do others have some thoughts on that one?
I mean, on the topic of arbitrage specifically, I think, so because we're moving from a totally synchronous world to asynchronous worlds between shards, if there's an arbitrage opportunity between two shards, then you can still execute it in the same way that if you have two exchanges with two separate order books, you can still do arbitrage there. But it will be less capital efficient than if you were arbitraging two single order books, two different order books on the same exchange.
Yeah, there's also something to note is there's incredible progress, I think, in the rollup space right now, and rollups are only going to be enhanced and enabled by Eth2 due to the very sophisticated data availability layer. And these rollup chains, at least today, are looking like highly, high throughput single chain mechanisms. And so, some sort of DeFi rollup chain could very well operate in the same way that Ethereum does today, but with incredibly high throughput. So there's some options. There's a lot of different things going on there. I think the idea that composability is broken in Eth2, I think is it's a bad meme. I don't think it's true. There's going to be some different stuff there. There's also going to be a lot of stuff that feels exactly the same. So keep your ear to the ground. Cool stuff coming. Thank you for that question. Where are we with coordinated multi-client testnets? Is there a plan to do incentivized testnets like early ETH1 days and like we've seen in some other chains? We talked a little bit about that. Quick recap: Topaz exists, Schlussley exists. One is for Prism, one is for multi-client efforts. And people talk about the ETH2 testnet. It seems likely that some version of Schlussley, might become the testnet. So that's kind of where we're at. But there's some experimentation, and actually there's a BLS upgrade that we have to do before we get there. Yeah, so on the incentivized testnets, there's going to be some stuff. We've been talking about it over here, trying to figure out the proper way. There might be some kind of parallel testnets. There might be the big testnet, and then some parallel, like week-long testnets where we try to have people break things in an incentivized way. Does anybody else thought about some fun stuff we might do there that we want to share? Oh, good. The answer is yes. As you've seen with the bug bounty program, we're kind of layering some incentives into this process to get more people involved, and you'll see some stuff with testnets very soon.
I mean, it could be argued that even like mainnet production phase 0 is kind of a testnet, and the reason being that there's no application layer stuff. So if things break, you know, you could potentially get some rewards, but not break,
Right.
real users and things like that.
Yeah, I think the difference between, well, yeah, cool, agreed. Next question from Rex Coleman. Okay, by including things such as staking and cross-chain, won't that increase the difficulty of providing security? How do you plan to upgrade your security? I don't know if I fully understand the question. Proof of stake is a fundamentally different security model. Ben has some thoughts.
There's some clarification lower down. He meant sharding rather than staking.
Right. Okay. So, who wants to take this one? I'm happy to, but I'm talking a lot. Okay.
I mean, like for sharding specifically, it's like if you mean security in terms of what are the security assumptions that we're making, I guess they're slightly different than the non-sharded world. So instead of having everyone vote on a single shard, you have these committees, and then you have assumptions around, okay, is the randomness and the sampling mechanism, is that fair? And the honesty assumptions become a bit worse because now in the sampling mechanism you introduce variance. So yeah, the security assumptions will definitely be worse in the sharded world versus the non-sharded world, but they're relatively like small trade-offs. And in terms of security upgrades, so if you mean like trying to improve the security assumptions, there's a bunch of things that we can do. So one of the things is we can try and improve the randomness, and this is what the VDF effort is for. Basically remove all forms of possible bias from the randomness, and you get a small security upgrade there. You could also consider doing what's called a secret leader election. So right now, when you elect a committee, that's done publicly. So everyone knows who will be this committee who will vote on this one shard. And this means that you will actually break against what's called an adaptive attacker. So an adaptive attacker is someone who, given public knowledge about who will be doing something in the future, is able to kind of adaptively attack them somehow. So that could mean a network level denial of service attack, because you know their IDs, so you can know their IP addresses, and then you can take them down. Or it could mean even more sophisticated things like bribing. You could just set up a smart contract saying, I will pay these people if they vote a certain malicious way. And so when you introduce like more fancy ways of doing the sampling, which are privacy preserving, where you don't have this leak of information using fancy cryptography, then you also get an improvement in the security assumptions regarding the adaptivity of your attacker.
Yeah, I think secret leader election is probably a must in the long run. The advantages there in security are vast. It seems like there's some people that have been looking into this, and there are increasingly somewhat simple and achievable ways to do this. And if you're interested in this kind of stuff, check it out. Great. Yeah, thanks. Good question. There's actually a question in the chat that I wanted to answer. Do you offer a simple way to try the official multi-client testnet, like a simple GUI? There has been much work on something called, I don't even know if the name's released. Yes, there's an interface in the works. And this will be discussed at Ethereal live tomorrow by, I believe, Carl P. Cuisin from our team and Colin Myers from Consensus. I believe those are the two talking about it. It's slick, it's cool, it's going to be really educational and get people to be able to try out validating before mainnet, and a similar interface will be used on mainnet. So check it out tomorrow. I don't know exactly when it is. If you scroll through day 2, it'll be pretty obvious based on the title. So thanks for the question. Cool. How does the reduction to 64 shards improve your user experience when trying to transact across shards? Great question. Thank you, Robert Clark. So this is something that came out of conversations leading up to and at DevCon in Osaka this year, or last year. Essentially, we had 1,024 shards. Shards were cross-linked once per epoch. Epoch's about every 6 minutes. At the time, it was 64 slots. Now it's 32 slots, but that doesn't really matter. So a big chunk of the shard chain would be cross-linked into the beacon chain every 6 minutes. At this point of cross-linking, this is when other shards become aware of things when shard A becomes cross-linked, other shards become aware of things on shard A and can then handle cross-shard communication from shard A. So this would happen every epoch, every 6.4 minutes. And this would then kind of put a base on how frequently asynchronous communications can happen. This is it's kind of shitty to go one way, but especially when you start going like 2 ways, 3 ways, back and forth, all of a sudden you're talking about like 12 minutes, 18 minutes, like high latency times for communication. And based on conversations at DevCon and leading up to DevCon, thank you for all of the input and feedback there. Just seemed like kind of an unacceptable latency and really kind of broke people's how they thought Ethereum can and should work, especially in this world of, as we discussed, these synchronous communications. And so the reduction to 64 shards. So there's a certain amount of load that cross-linking bears upon the beacon chain. So to be able to cross-link, instead of cross-linking every shard every epoch, we cross-link every shard every slot. To be able to handle that amount of load, we had to reduce the amount of shards, essentially. But the gain there is that at every slot, optimally, every shard can be cross-linked, and thus the next slot, every shard can become aware of transactions and consuming of things from the other shards. And so that's the trade-off there. Is it's kind of a user experience versus throughput trade-off, as you put it. It's a gain in user experience. Other thoughts on that one?
I mean, I have a couple points. One is that, like probably long term, we do want to increase the number of shards, but in the short term, it's probably a good thing that we don't have that like a crazy number of shards. And the reason is that we're going to start from 0, and we want to kind of limit fragmentation to an extent. And having only 64 shards will, keep the fragmentation in the early days to a reasonable level. On the point of user experience, and potentially these cross-links taking a long time in the previous design, we did have like all sorts of fancy ideas whereby, you could do optimistic cross-linking before like before you get finalized cross-linking, because really finality is a spectrum from the point where a block proposer has created a block, and then it starts, getting attestations, and then these attestations go on chain, and then you start the finality process, which is kind of a 2-step process, justification and then finality. And basically, and even when you get to the point of finality, that's not like 100% finality. Is what's called like economic finality. So, this finality could be reverted, but it will just cost an attacker a lot of money. And so, what you could do is you can set up infrastructure whereby you take a risk-informed decision, whereby you reduce latency, but you take a bit more risk. And I still think that this infrastructure will eventually be deployed, even in the new design. So, even 12 seconds, that's like ridiculous latency, right? Imagine, using, paying for something at a restaurant or whatever at the supermarket, and it takes 12 seconds. You really don't want that. So all these techniques will come in where the latency will be extremely low, but it does mean that the DevX, the developer experience, will be harder because you need more sophistication there.
Yeah. So the layer 2 TLDR is the layer 2 mechanisms on making the UX of fast communication between shards is probably still going to be built out, even though we have a much better kind of layer 1 synchrony, layer 1 communication. Cool. We have 5 minutes left. Hal Finney, welcome Hal Finney, wants to shed light on how far we come along with phase 1 and phase 2 and timelines. Xiao-Wei, you've been spending a lot of time on the phase 1 specs. Do you want to give us an update?
Okay, so for the phase 1 shard, there will be only shard data for the shard block. So just remind that there's no real contract transaction in in the phase 1. So I think the research is like almost done according to Vitalik's version, and so the hard problem are like most of them are solved, but for the implementation and before the implementation, we are currently specify the algorithm into the repo. So we have some ongoing work on the phase 1 spec. But so this is also a good time for people to join, to look at the GitHub repo to give some input on this. And about the timeline, I would say, so if things are going well and we are currently have some client teams that are both working on the phase 1 and phase 0. So I think it would be sooner than we expected.
Great answer. Yeah, a lot of the work on phase 1 right now is some testing of the specification and refinement. Kind of this like, okay, we have something that works, but the cleaner we can make it right now, probably the easier it is to implement, to reason about. So Xiao-Wei and I have been spending a lot of time kind of going back and forth on refining these phase 1 specs. There's still some work to do on like defining the network spec and things like that. And I know Mikhail from TXRX has been looking a lot into this ETH1, ETH2 merger and plans on doing some phase 1 dev inside of Teku. Terrence from Prismatic Labs has already done kind of a quick implementation of what's the phase 1 specs and at least the state transition. And similarly, some of the other clients are looking into it. Phase 2 is this like big nebulous thing. The thing that we know we want to do is integrate ETH1 into this new upgraded consensus ETH2 mechanism. And there's a lot of work going on that. The guest team has built a mechanism to prototype kind of deferring the ETH1 client consensus to the ETH2 mechanism. And like I said, Mikhail's been looking at this. There's kind of a good little movement going on in that. So progress. I think we have like 2 minutes left. Does anybody that's on the panel have anything to add just to the ETH2 process, where we're at, some maybe an interesting tidbit that we didn't know? Just some thoughts.
I mean, one kind of relatively recent piece of research that the Eth2 team has been excited about is these polynomial commitments based on pairings. So this is like probably mumbo jumbo words for most of you, but basically it's like technology that can replace Merkle trees. And this could like significantly affect the Eth2 roadmap if we can like really get it to work. I guess in two ways. Way number one is that in phase one, it could dramatically simplify the proof of custody. So like there's this one module in phase one where, you know, they could potentially, we could trash everything and start from scratch and make it dramatically simpler. And then the other thing is that it could be like, it could replace the Merkle trees that keep track of states. So what we have right now in ETH1 is like these Patricia Merkle trees, and you know, you have binary trees and you have all sorts of Merkle trees. And like one of the big reasons why we went down this execution engine route is because you know, we didn't really want to go with state rent, so we went with this.
I think we're about to be just cut off. It looks like the webinar is just going to end.
Oh, you're okay. Justin, finish what you were saying.
Okay, I'm sorry. Go on.
Thanks, Danny. Yeah. Go right ahead, Justin.
Right. Okay. So like one of the big difficulties of phase two was this question of state. How do you handle state? Because it's, you know, you need to be able to sync shards quickly and things like that. So one early idea was state rent, which we kind of, you know, we realized it was complicated, so we didn't want to do state rent. And then we went to another solution, which is basically stateless clients. But then stateless clients, there's a trade-off there, is like you have these really long witnesses, like all these Merkle paths, which add a lot of data overhead. And so one of the approaches that we had is, what if we have execution engines? And these execution engines basically allow you to define, you know, at the application layer, what type of statelessness you want to do. So it allows for experimentation and progress over time. But it's possible that we found like the state commitment, so this pairing based vector commitment, which is kind of the solution to rule them all. And so there would be much less of a reason to push forward the execution engine route, and we can just go with the much simpler and more traditional kind of single execution engine that the blockchain space has. So, you know, that would be great news if we could, you know, push it forward and also dramatically simplify phase two.
Absolutely. I'm going to leave you with this. ETH2 is an upgraded consensus mechanism for Ethereum, for you. ETH2 is super fucking exciting, but it's going to take some time. We're rolling it out. Get involved, try out some validators, and you know, check out the future of Ethereum. Tomorrow, there's a lot of great ETH2 content at program.ethereal. Thank you, DeFi Dad, for putting a lot of this together. Really appreciate you having us at last notice, and I hope it was fun for everyone.
Hey, thanks everyone for joining. Thanks so much, Danny, for queuing this up for us. And bye, everyone.